Good afternoon, everyone. These are the pre-launch briefings for our Taurus XL Glory and Alana missions. And we'll be having three briefings today. Our first briefing will be the pre-launch news conference. We'll follow that with a Glory mission science briefing, and then we'll conclude with a briefing on Alana. So we'll start now with our pre-launch news briefing on the Taurus XL Glory launch coming up on Wednesday morning. We'll begin first with Joy Brethauer, the Glory program executive from NASA headquarters in Washington. Then we will hear from Omar Baez, the NASA launch director for this mission from the Kennedy Space Center. We'll hear next from John Brunchweiler, the Taurus program director from Orbital Sciences Corporation. Brian Pfaffel, the Glory project manager from the Goddard Space Flight Center. And First Lieutenant Benjamin Warr, the launch weather officer from the 30th Weather Squadron at Vandenberg Air Force Base. And we'll begin first with our program executive, Joy Brethauer. Joy?
Thank you, George. I'd like to have the first graphic posted, please. Now, I'll start by talking about why Glory is important to us. The graphic will be coming up as I'm speaking. Glory is the next launch in the President's Climate Initiative to address key climate problems and is NASA's next Earth-observing science research mission that will join 13 other Earth science missions that are currently orbiting and operating. Glory will improve our understanding of how the sun and tiny particles called aerosols affect Earth's climate changes. The scientific knowledge obtained from Glory will enable researchers to better understand the effects of aerosols and solar irradiance on climate and more accurately predict the future of Earth's climate changes. As global climate and weather affect our natural resources and impact our lives, this understanding is also essential for making scientifically based policy decisions that are related to environmental change. NASA's rigorous standards, processes, practices, and testing have prepared both the observatory and the launch vehicle for the upcoming Glory mission. Our panel here represents the combined efforts of people all across our nation supporting the Glory mission. Through the dedicated teamwork of government, industry, and academia, we are on track for launching Glory. As Glory's program executive for the Earth Science Division, I am responsible for the overall technical, cost, schedule, and program management of the Glory mission for NASA headquarters. Project management for the Glory mission is provided by NASA's Goddard Space Flight Center. Later today, in a separate science briefing, we'll have the Glory mission scientists further explain the mission science. The Taurus XL launch vehicle was procured through NASA's Launch Services Program at Kennedy Space Center. The Orbital Sciences Corporation is both the spacecraft integrator and the launch services provider. After the Taurus XL rocket launches the Glory Observatory, it's going to go into an Earth-observing orbit, where it will then ascend into the afternoon constellation and become the sixth satellite to join what is also known as the A-Train. The Glory Observatory's design supports 3 years of on-orbit operations. The low Earth orbit A-Train constellation consists of multiple spacecraft flying in close proximity and is the first ever super observatory to provide near simultaneous observations of the Earth, including land, atmosphere, and ocean. I'd like to have the next graphic posted, please. That's coming up. The Glory mission responds to the Intergovernmental Panel on Climate Change by continuing and improving NASA's Earth science research of climate change. Changes in the composition of Earth's atmosphere or in solar irradiance can lead to global climate change. The Glory mission has two science objectives. One objective is to use Glory's highly accurate and sun-pointing total irradiance monitor instrument to continue our critical 32-year record of measuring the sun's direct and indirect effects on climate. By determining the sun's major effect on climate, this will enable researchers to better understand the Earth's energy budget. The second objective is to use the first ever measurements of polarization from Glory's aerosol polarimetry sensor instrument to increase our understanding of how natural and man-made aerosols impact the Earth's climate. Glory is NASA's first satellite that will make unique, highly accurate measurements of light properties as a means of identifying the size, shape, and composition of aerosols. Now, as far as what are aerosols? Aerosols are tiny, airborne, solid or liquid particles sized from nanometers to micrometers that may be either natural or man-made in origin. And I'd like to have the next graphic. Examples of natural sources of aerosols include desert dust, as is illustrated here, and the next graphic, please, and volcanoes. While man-made sources of aerosols come from sources like air pollution and intentionally burning trees, all of which, depending upon their contribution, contribute to either the warming or the cooling of the Earth. The largest uncertainty in our understanding of the Earth's climate is the aerosol climate effect. Glory will help researchers better understand how aerosols influence solar energy in the Earth's system. Along with these uncertainties, there are uncertainties associated with the formation of clouds, as well as the properties associated with clouds. Glory will also help us to improve atmospheric models that predict aerosol transport. While remaining airborne for at most a couple of weeks, these tiny particles can be transported thousands of miles across the globe. Glory will aid the researchers' understanding the global distribution of both natural and man-made aerosols, as well as how they interact with other components in the atmosphere as they are transported globally and affect Earth's climate. In summary, the Glory mission will provide the highly accurate aerosol and solar irradiance measurements that are vital to improving climate models and more accurately predicting Earth's future climate, all of which are essential resources for making scientifically based economic, health, and policy decisions related to environmental change. And with that, I'll turn it back over to George.
All right, thank you, Joy. And now we'll go to Omar Baez, who is the NASA Launch Director from the Kennedy Space Center, to talk about our upcoming flight. Omar?
Thank you, George. Good afternoon, everyone, and thank you for attending today's brief. I'm very fortunate to be here representing scores of men and women from NASA and the Launch Services Program and Orbital Science and the Launch Systems Group. These folks have worked a lot of long, difficult hours in the past 2 years, getting through Taurus return to flight activities and preparing Glory and Alana for launch this Wednesday morning. If you could, please roll a little video we have for you. The Taurus shares a lot of commonality with the Pegasus launch vehicle, minus the wing and a stage 0, which is the L-1011. This is stage 0 for the Taurus you're seeing in this roll here. The stage 0 is a Castor 120 motor. It provides upward of 360,000 pounds of thrust. It's being hoisted onto a pedestal at 576E. And what you see here is the combined Glory spacecraft, the third stage, the second stage, and the first stage. It's all bolted onto the stage 0. And as you can see, we depend on a lot of mobile cranes, bucket trucks, and scaffolding to put that whole stack together. It's a very austere operation. I'd like to say it's in the minimalist style or feng shui, very clean pad. This morning, we held our launch readiness review. We have absolutely no actions. We're clean, green, and ready to go. The operation tomorrow night takes about 4 hours. We have 2 built-in holds during the countdown, one that occurs at T-minus 45 minutes and lasts for 15 minutes, and one at T-minus 12 minutes that lasts for 5 minutes. Our launch management team will be on station at about 10 p.m. local. The folks will then configure the facility and range. We will power up the launch vehicle and go through the power systems checks and the flight termination systems checkout. I will conduct conduct my first pull at L minus 56 minutes in anticipation of coming out of the hold at T minus 45 minutes. I will perform my second pull prior to coming out of the hold at T minus 12 minutes. The spacecraft will then transfer to internal power for its final flight configuration. And at T minus 5 minutes, I will give my concurrence to launch. At T minus 1 minute and 30 seconds, the auto sequencer is initiated and will configure the vehicle for launch. We have a 47-second window tomorrow, and we are targeting the middle of that window, which is 2:09:43 local. Back to you, George.
All right. Thank you, Omar. And now to John Brunchweiler, the Taurus Program Manager from Orbital Sciences Corporation. John?
Thank you, George. First, it's an honor to be here, and I'd like to thank NASA for giving us the opportunity to carry the Glory spacecraft into orbit. But I want to tell you a story, and in fact, I recognize some faces of the press out here. 2 years ago, almost to the day, we were here with great enthusiasm of the OCO mission. It didn't turn out very well. I mean, it was quite a disappointment for all of us, the science community, NASA, Orbital, and many individuals that worked on that mission. So what's been happening over the last 2 years, in fact, immediately after the failure, NASA and Orbital, as a team, formed an investigation team. We went through the data from the flight, determined what the problem was. And this is a long process. We ended up then coming to a pretty robust system for the fairing deployment, and that was the issue that failed the mission for OCO. As a result of all the engineering work, retests, testing, every subsystem of this fairing, we arrive here today with a flight proven. In fact, the same system that we're flying in 37 hours has flown 3 times already on another orbital vehicle. That's the Minotaur 4. So we know that the basic design works very well. Now, that wasn't the only thing we ended up doing. Both Kennedy and Orbital not only looked at the fairing, which was a problem, but the entire vehicle. We wanted to make sure we didn't miss anything else and looked stem to stern and fixed all that we could. It was quite an effort, and from that, I think we have great confidence going into the launch event. Now, if you could pull up the first image, and I'll tell you a little bit more about the Taurus, and you can kind of visualize some of these elements. Now, Omar, he talked and showed you a video about how the assembly of the vehicle happens. There's really 3 major components. On your left, there is the stage 0, as Omar indicated. That's put on the stand first at the launch site. And then the picture in the center there is the upper 3 stages, which are put together and tested inside a building here on Vandenberg by Orbital. And then probably the most, well, one of a lot of interest is the image on the right. That's the fairing. So the fairing that you see there, we deliver to a clean facility called the Payload Processing Facility at Vandenberg. And what that does is it puts it in a clean room and meets the spacecraft there. So if you could put the next image up, please. On the right, you can see where the Glory spacecraft has been mated to the top of the Taurus structure with the half of the fairing around it. Now what that does, we'll add the other half of the fairing within that clean environment, and that provides humidity, temperature, contamination control for the spacecraft. And you do that in a clean area because, as you've seen so far of this pad, when it goes down to the site, you get wind, rain, dry air, wet air. We've only had one rattlesnake sighting this time. Last time I think we had a couple of frogs and a rattlesnake. So there are some things to avoid, and this, by encapsulating the payload, it keeps that safe. Now, we have another passenger with us, the Alana, and you can see that on the lower left. It's sort of in a curious spot. Your typical satellite rides at the top of the rocket. Nose cap comes off, and then the satellite's out front. Well, that's the case for Glory, but the Alana spacecraft assembly, if you will, it's actually a carrier called a P-pod with 3 small CubeSats, which you'll hear a lot more about at a later briefing following, I think, a couple more briefings here. It's the last one today. But it's behind, it actually faces aft during flight, and it's next to our Stage 3 nozzle. So you can kind of see that nozzle in the picture. And well, I'll just continue a little bit more. It's kind of interesting. We actually put a thermal protection system around this P-pod canister for the Alana mission to protect against any heating that may occur from the Stage 3 nozzle. And all kinds of, again, lots of analysis. We have gone over every aspect of the vehicle, every aspect of the mission. If you could show up the next slide, please. So this is the way it's going to look. Probably later today and certainly tomorrow for day of launch. Nice clean pad. We've taken off all the protective covers, and we enter into the count as Omar described. And once we get to T0, be sure to listen. There's a few key events. You're going to hear lift off, and then depending on where you are, if you're local here, there'll be quite a bit of a delay before you actually feel the rumble of the Stage 0 engine. So don't be alarmed if you see the flame, but it's, where's the sound? It's coming, don't worry. If you're listening to the countdown, you'll also hear call-outs of Stage 0 burnout, Stage 1, Stage 0-1 separation, Stage 1 ignition, as we drop these stages away, because we burn the propellant, get rid of the weight, and then on to the next stage. There's probably a key event that's happening that certainly I'm going to be listening for, and that is about 3 minutes into the mission, and you'll hear confirmation of fairing separation. So that's certainly I'm going to be listening for that. I know a lot of others are too. 13 minutes later, the Glory spacecraft will reach orbit at the end of our rocket, and we will gently push it away. And then 10 seconds after that, the Alana P-pod canister will open, and then the 3 P-pods come out. And then our mission is done. So, we're about 2 days away from the end of this story, at least my story, and then the beginning of the spacecraft. So back to you, George.
All right. Thank you, John. And for that spacecraft story, we go to Brian Faithful, the Glory Project Manager from NASA's Goddard Space Flight Center. Brian?
Thank you, George. I'd like to thank everybody for being here today and tell you how excited we are for the launch of Glory. I'm happy to report that we've finished all our processing here at Vandenberg, and Glory is ready for its launch early Wednesday morning. If you could start the first animation, I'd like to talk a little bit more about the mission itself. As Joy mentioned, Glory is a key part of NASA's climate research program, and it will join 5 other satellites in the afternoon constellation that are Earth observing. Glory is a unique satellite in that it is really 2 very different scientific missions in one. It contains a sun-pointing instrument that will that will measure solar energy, and an Earth-pointing instrument that will study aerosols. The Total Irradiance Monitor was built by the University of Colorado's Laboratory for Atmospheric and Space Physics in Boulder, Colorado, and it will continue an uninterrupted 32-year spaceborne data record of the total solar irradiance measurement. While the aerosol polarimetry sensor built by Raytheon Space and Airborne Systems in El Segundo, California, will help scientists better understand the role of both man-made and naturally occurring aerosols in the atmosphere. The APS instrument is also supported by 2 cloud cameras, which were built by Ball Aerospace and Technology Corporation, also in Boulder, Colorado, which will assist APS science in cloud clearing activities. Supporting the instrument suite is the Glory spacecraft. The Glory spacecraft is from an existing NASA program that was terminated many years ago. It's been extensively modified and refurbished. That work was completed by Orbital Sciences Corporation in Dulles, Virginia, the same folks that will be flying Orbital as after we launch for the operations phase of this mission. If we could go to the next video. I'd like to talk a little bit about the processing that we had here at Vandenberg and tell you what to expect after we separate from the Taurus vehicle itself. We arrived at Vandenberg on January 11th after a 3-day journey across the country. After a very quick inspection of the hardware and the ground support equipment, we unpacked Glory, moved it to the its temporary home and began the process of configuring for launch. Over the next couple weeks, we spent time visually inspecting the instruments, the spacecraft, the solar arrays. We put the observatory through a full battery of electrical tests, and then we were ready to fuel. The fueling of the spacecraft marked a major milestone for me personally, as it represented Glory's last standalone activity by itself. From that point on the program on forward, we were going to meet up with the Taurus and we'd work together to get us to the launch. And I must say that the Glory processing has gone, and Glory and the spacecraft and the launch vehicle processing has gone very well. As John mentioned in his presentation, Glory is buckled atop the Taurus right now, and we're ready for its ride to get to space. Once we separate from the launch vehicle, the spacecraft will start a planned series of events that will ultimately result in solar array deployment. Depending upon the insertion orbit's initial conditions, solar array deployment is expected about 21 minutes after the separation event, all the way out to about an hour and 15 minutes after the event. We'll be using NASA's Tracking and Data Relay satellite to monitor spacecraft activities for about 12 hours after we launch, but we will be commanding the spacecraft through our ground station contacts. During those first several ground station contacts, we're going to be performing some key operations for the spacecraft. We will verify its state of health. We're going to open up a propulsion system latch valve. We have to take the -X solar array, rotate it 180 degrees towards the sun, and then we'll adjust the beta angle offset of those arrays to maximize our electrical power. Over the next several days after that, we will be bringing on other spacecraft systems, and in about 7 days after the launch, the spacecraft should be completely checked out. After that, we're going to move into the next 20 days, which are very critical days, in that we will perform a series of propulsion maneuvers to raise our altitude and enter into the afternoon constellation. That'll put us at about 29 days after we launched, and then we will spend the next days all the way out to the 45th day commissioning the instruments. And once that's complete, Glory will be configured fully for science operations, and then my job will be complete. Before we move on to hear the weather briefing, which is very important for tomorrow night, I want to just tell you once again how excited and pleased my team is to be at this point in the program. We've worked very hard to get Glory configured for launch, and I want to ensure you that Glory is ready to go to work. And that's it.
Thank you, Brian. And now for the weather forecast, First Lieutenant Benjamin J. Wauer, the launch weather officer for tomorrow night's launch from the 30th Weather Squadron here at Vandenberg Air Force Base. Lieutenant Wauer.
Thank you, George. Good afternoon, ladies and gentlemen. February is the most atmospherically dynamic month for the Central California coast, marked by alternating patterns of high and low pressure systems moving through the area. This past week, we saw a rather intense low pressure system move through Vandenberg, which produced heavy rainfall, thunderstorms, and strong winds. The pattern remains unsettled as a cutoff low will dive down from the Pacific coast, from the Gulf of Alaska, and linger off the California coast. Cutoff lows develop as low pressure systems lose upper level jet support. They are literally cut off from the flow and can remain stationary for several days at a time. This is our main forecast challenge because the nature of flow makes them difficult for weather models to predict their timing and their movement. Currently, skies are generally clear over Vandenberg, as the majority of the clouds associated with the cutoff low are to the northwest off the northern California coast. The low is forecast to remain to the west of Vandenberg Air Force Base and move to the south of Central California through today and tomorrow. The main concern we have at this time is that the proximity of the cutoff low could produce cumulus clouds overhead of the launch pad or along the vehicle flight path. This would violate a range safety launch commitment criterion for cumulus clouds. That being said, the models and observations are beginning to agree that the weather conditions for the launch window will remain favorable. The forecast for the launch window of 2:08 to 2:11 local on February 23rd will be cumulus clouds of 1/8 coverage from 3,000 to 5,000 feet. Cirrus clouds, 3/8 coverage from 22 to 25,000 feet. Unrestricted visibility with winds out of the southeast at 12 to 18 knots. Temperatures will be in the mid to low 40s with an overall probability of violating T0 of 10% for those cumulus clouds. And finally, the 24-hour scrub forecast for February 24th will see an improvement in conditions as the cutoff low moves out of the area and high pressure begins to take hold. We're still going to see some of those high-level cirrus clouds linger around from 22 to 25,000 feet. Visibility will remain unrestricted. Winds will switch from the northwest at 12 to 18 knots, and temperatures will be in the mid-40s. That gives us a probability of violation for our 24-hour scrub forecast of 0%. And that's all I have, George. Back to you.
All right, thank you, Lieutenant Wauer. And now we'll take questions. We'll start first here at Vandenberg, then we'll go to the Kennedy Space Center where we understand there are some questions, and then come back here for any final questions. So we'll start here at Vandenberg, here with Nora Wallace. Please give your name and affiliation when the mic comes to you.
Hi, Nora Wallace, Santa Barbara News Press. John, you spoke a little bit about looking at the vehicle from, I think you said stem to stern, and you said we fixed all that we could. Could you elaborate a little bit on that and tell us, maybe what else might have been found on the rocket, and is it kind of the new improved Taurus?
Sure, right. Obviously the fairing was the focus, and we put more energy into that because it did. We were able to identify the cause probably within 6 to 8 months. It sort of, this discovery sort of comes out over time. And then we started in on the redesign process for the fairing itself. But we didn't want to stop there. So we held what we call an independent review where we have engineering staff from both Kennedy and Orbital that aren't associated necessarily with Taurus look at both the design aspect, all the processes that we go through to make sure that for example, our analysis for, pick an example, structure strength, say, that had nothing to do with the fairing deployment, that analysis was performed correctly, that the electrical systems were done, the guidance, navigation, and control systems, all of the assumptions were correct in the models. I mean, it's an excruciating process, but we left no stone unturned. We did make some modest hardware improvements. We changed, for example, to a later ordnance devices. Okay, you can't test them because then they're done. So we moved to some newer lots that had a better test history. For example, that again didn't have anything to do with the fairing deployment, but nonetheless will improve the overall reliability of the vehicle. So those are some of the things that we did.
Janine?
Janine Scully, Santa Maria Times, Lompoc Record. Omar, from NASA's standpoint, what's your level of confidence in Taurus going forward Wednesday?
Sure. It's kind of like there's that cold pool and you got to dip your toe in it. We've done everything we can. We've looked at that vehicle from a systems level down to the piece parts level. We've checked everything. We're as comfortable as we're going to get. We really need to get this launched and to be successful. And I think the whole team has done some soul searching and looked deep at everything we've done. I don't think we can uncover anything else. And with that gives me a lot of comfort. Yeah, I will be crossing my fingers, but that's just my superstitious side. But we have done everything we could.
All right, we're going to go to Kennedy and take a question or two from there, and then we'll come back and take some follow-up and additional questions here at Vandenberg. So if we could go to Kennedy for the questions.
Hi, thanks for taking my question. Denise Chow at space.com with the question for Joy Bredauer. Just wondering what the cost of the Glory mission is and how, if at all, the Glory mission and its future is affected by the proposed FY12 budget.
Starting off with the question of cost, the Glory mission costs about $424.1 million, and that's the cost of the mission, including the on-orbit operations. The second part of that question, could you repeat that because I could barely hear you?
Yeah, sorry. Just how the Glory mission in the future, if at all, is going to be affected by the proposed FY12 budget.
The best of my knowledge right now, the Glory budget, I mean, there's been a commitment to support the Glory mission. And as far as I know, we are confident that that is unaffected at this point in time. Again, that's one of the most important initiatives in the Earth science portfolio right now. And unless that changes in the future, of course, we don't know what the future holds. But right now, the commitment is firm, it's there, and we will be going forward to support the mission.
Further questions of Kennedy? All right, that's all from Kennedy. So we'll come back here. Do we have any questions in the back from anyone back here? All right, then we'll come back here to the front. Nora, you can pick up again.
Nora Wallace again, Santa Barbara News Press. Joy, you could answer this one. In terms of understanding global climate change, can you rank Glory's importance in the A-Train to give us a better understanding of how important it is to have that particular spacecraft in the constellation?
Well, right now, I'm going to say that you could hold your question for the next science briefing where you'll get the real experts for the science. However, I will say that Glory, in combination with observations from the other spacecraft that are currently on orbit with the A-Train, will provide a substantial amount of insight and clarity, as I had spoken before, about how aerosols impact our Earth's atmosphere, and it'll also go into looking at how the atmosphere, the aerosols in the atmosphere in combination with the changes in the solar energy will impact Earth's climate. So I'd recommend holding it for the true experts on the panel a little later, but it's very important. I mean, obviously global warming, we've heard a lot about global climate changes. I mean, this is our planet, our Earth. I mean, we really need to bring it down to brass tacks. All you have to do is step outside and you either have a hazy day or you have a clear and sunny day. We're looking at supporting the planet for future generations, and we really need to get serious as a civilization about truly getting the data that we need to understand how, in fact, we as a community are impacting our own backyard and the air that we breathe. So, you're welcome.
Janine, do you have a follow-up?
How many days on the range do you have, and are there any impediments in terms of satellite charging beyond 48-hour slip?
We have the 23rd and the 24th as a backup. There is some other testing on the range, but we'll take, if we need to negotiate that, it's a normal process.